Hey everyone. So today we're going to work on rational exponents day 2 and make sure we feel really good about this topic. So first thing, we're just going to do a little warm up here. You can pause the video, try these out, compare these two problems, okay? When you're ready, you can unpause and I'll go through them. So this negative on the outside, okay, that just means negative 16 to the 3/4, 4th root of 16 to the third. Notice how the negative did not get impacted by any of this power because it's on the outside, not being impacted. I've got negative 2, 4th root of 16. What four things multiply to 16? To the third gives me negative 8. Versus the 4th root of negative 16. No solution. Doesn't even matter. Don't have to keep going. We've got a negative on the inside because it was in that parentheses. Okay, now take a look at this next one. This one's a little different. Okay, again, if you want to pause, try it out, and then we'll come back. So take a look at negative on the outside, so I'm just going to leave it. Negative 2/3 power, that means I'm going into the denominator here to the 2/3. 2/3, again, just means what's the cube root of 125? What three things multiply to 125? 5 times 5 times 5. Take 5, and we're going to square it. So this would be negative 1 over 5 squared, which is negative 1/25. And the only thing different here, guys, look at this one. Negative on the inside. That means 1 over negative, cube root of negative 125 to the third, now, or to the second. My question is, can you take the cube root of a negative, do three things multiply to a negative number? Yes, right? What three things multiply to negative 125? That would be negative 5. So now it's 1 over negative 5 squared, which is positive 1/25. Again, because that negative was impacted, okay, I guess we're doing a pentagon. That negative 5 was impacted by the exponent. So when I squared it, it became positive. All right, so there's your things that are slightly different. Again, just pay close attention to where the negative is. That's my main lesson on that. We're going to move on to some more exciting ones here. So take a look at example 1 and 2 and 3, all pretty close together in terms of simplicity, but be very careful. So when we have a power to a power, okay, power to a power, remember we're multiplying. How do we multiply fractions? We multiply the top, multiply the bottom. So this is 49 to the 12, 4 times 3, over 24. Well, 49 to the 12 24ths, excuse me, is really just 49 to the 1/2. Okay, and if we can simplify this number, 49 to the 1/2, we can, right? What's the square root of 49? 7, then we should simplify. So we get just 7 for this whole answer here. Okay, now the next two are both numbers that we're not going to be able to simplify, but we do want to get it down to one base. So for example, 5 times 5, here's the trick. You keep the base and add the exponents, okay? What's 1/2 plus 5 halves? 1/2 plus 5 halves is 6 halves. Remember, keep the denominator, add the numerators, which is really 5 to the third. And actually, we can simplify here. This is just 125, 5 to the third power. Biggest mistake people make, maybe you were tempted to do it, 5 times 5, they make this 25 to the 6 halves. Okay, if I gave you x squared times x cubed, you don't make this 2x, right? We just keep the power, keep the base, and add the powers together. So same thing, keep the base, add those two powers. And 7 to the 2/5 times 7 to the negative 12/5. Add these fractions, guys. Fifths and fifths, so we're good to go. This really is 7 to the 2/5 plus negative 12/5, if you want to write it out, which is 7 to the negative 10/5, which is 7 to the negative 2nd. We would never end with a negative exponent. 1 over 7 to the 7 to the 2nd, which is 1 over 49. I just wanted to warn you, I predicted these incorrectly here. If I got something like 5 to the 1/3 as a final answer, that's just all you could do because you can't take the cube root of 5 in terms of finding a nice, there's no fraction or nice number that we know for that that's rational. So we would just leave it as 5 to the 1/3. If you can simplify, such as 5 to the 3rd or 1 over 7 to the 2nd, definitely simplify. Okay, so this was the final answer, 1/49. Okay, we're going to try a few more here, and then we have some we'll do in class. So take a look at 4. 4, we're multiplying two things together. 2 times 3, 6. Don't forget that those numbers that are just coefficients, those act like normal. So if we're multiplying, you multiply them. Then I've got m and m. We have the same base, we keep it, and we add the exponents. -5/2 plus 1/2 is -4/2. -5 plus 1. Well, -4/2 is -2. And we flip this guy to the bottom of the fraction. 6 over m squared. Again, because we don't end with any negative exponents. Whoa, 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 whoa. Okay. So 6 over m squared, final answer there. All right, 5 and 6, very similar, but I want to take a second to look at 5 and 6. 5 is a little more difficult. Here's what's going on for 5, okay? Basically, we're distributing, okay? Now, as we distribute, we have -5 times 3, that's -15. What do I do with those y values? Well, I have the same base. I'm going to add the exponents. I want you to think, what's the exponent right here? Okay, that exponent would just technically be 1. So really what I'm doing is 1 plus 9/10. Now, if you remember from algebra way back in your life when you added fractions, 1 plus 9/10, we want to create this to be both in tenths. So we're going to multiply this guy by 10 over 10. So 10/10 plus 9/10 equals 19/10. So overall, 1 plus 9/10 gives us 19/10. And if that is bothering you guys, I'm sorry, that's a adding fractions problem. We got to figure those out for our Algebra 2 class. So again, we're adding 1 plus 9/10. And we just make those the same denominator. So really, we can just treat this as, since we're going to use it again, y to the 10/10, since that's the same thing as saying y to the first. Okay, now, next step here, distribute to the next guy. That would be -20, 5 times 4, y to the, okay, I take 10 plus 3, that would be 13/10. Okay, and then we pause. Biggest mistake people make right here is they add these two together. Now, I know it's tempting, but what type of things can you add together? If I gave you guys y cubed plus y squared, and I said, all right, add them together, you would hopefully say, we can't, right? Those are not like terms because they need the same exponent. So guess what? If I asked you, is 19/10 the same as 13/10? Is that the same value? No. So I actually have a final answer right here. I cannot combine those again because the exponents are not the same. If I had both of them are 19/10, I could of course add them together. Okay, that's a tough one. Number 6, kind of similar idea here, except nicely. I have a fourth for you, I have fourths, and I have fourths again. So this is going to be a little quicker because I don't have to do anything special. So I'm distributing. Keep the base, add the exponents, 1/4 plus 5/4. Distribute, keep the base, 1/4 plus 3/4 is 4/4. And I simplify. 3/2, m to the first. Is 3/2, are 3/2 and 1 the same number? No. So I cannot combine these. Again, the only things you can add together are like terms, things that have the exact same variable and the exact same exponent. All right. So again, pause if you need to. We're going to wrap this up with these last two examples. Okay, so example 7, we've got something on the outside, that 4/3, and we have a product in here, so we can distribute to each piece. My recommendation, just write it unsimplified first. So 27 to the 4/3. A to the, all right guys, we have to multiply 3 times 4 over 8 times 3. 12 24ths. So we went to 27, we went to A. We got to go to B. b to the, remember this is like negative 2 over 1, negative 4 times 2 over 3, so negative 8 thirds. Okay, we did our distributing, and now we're just going to simplify. So 27 to the 4 thirds, remember, cube root of 27 is 3, and 3 to the 4th is 81. So again, cube root of 27 to the 4th. So 3 to the 4th. What 3 things multiply to 27? A to the 12 24ths is just 1/2. Let's simplify those fractions. And negative 8 thirds, we can't simplify 8 thirds, but we do have to move this to the denominator because it is a negative exponent. We can't end with that. So 81, a to the 1/2 over b to the 8 thirds. All right, and last but not least, we're going to try out example 8 here. Example 8, I've got x's and y's. I can only have one of each base, so I do have to simplify if I see x on the top and x on the bottom. Now, if you're just looking at the x's, remember, if I gave you something like this, you would say, oh, subtract. Well, guess what? That's exactly the same as what we're going to do here. So we're going to subtract 3/4 minus 1/4. And we get positive 2/4. That means we're in the top of the fraction. I'll bring back my y's here. 5/6 minus 11/6. 5/6 minus 11/6 gives me negative 6/6. It's hard to say, which is really just negative 1. Oh gosh, negative 1. Okay, and that being said, if I get negative 1 as an exponent, that just means it's y to the negative first, which means it's in the denominator. So it's really just y to the first. Or you can think this denominator has 6/6 more than the numerator. I should stop saying that. So x to the 2/4 is really x to the 1/2. And then we just have y in the denominator. And again, that was because we had one full value, right? 5/6 over 11/6. 5/6 minus 11 is negative 6/6, which means it's in the denominator as a positive. And that's about it, guys. So again, take a look, pause if you need to, go back. Bring in any questions tomorrow. You'll see we have some fun ones to do in class, 1 through 4. If you want to take a look at those ahead of time, that is what we're going to be looking at. So thanks for watching and hope you have a great rest of your day.